Imagine this unit cell of an FCC lattice. So you can see that this is a cube, and in the cube I have marked these points which are the centers of the spheres which occupy this lattice, and these centers are at the vertices and also at the face centers. So this is an FCC lattice. This unit cell is of an FCC lattice, and most of us, we know that the spheres centered at the green and the red dot, this green dot here and the red dot here, they touch each other. And there is an interesting question, like whether the spheres centered at the red dot and the blue dot, they touch each other or not. Do the spheres centered at the red dot, there must be a sphere here which will be of some size, and there must be a sphere here which will be of some size. Do they touch each other or not? That's the question. So let's see how to solve this. Consider the line joining the green and the red dot, the spheres of the the centers of the two touching sphere. So this distance here from this point to that point to the red point, from the green to the red, if you move along this line, you will be traveling one radius and the other radius from here to here. So whatever this distance is, this d must be equal to 2r. This is the condition for any two touching spheres, or even circles also. In 2-dimension also, if you have a circle and two circles touch each other, then the distance between their centers, that d, should be equal to 1r plus 1 more r, 2r. If the distance between the centers is greater than 2r, then they won't touch each other, because there will be some empty distance here. This is r and this is r, and there is some more distance here, x. So if the distance between the centers is more than 2r, they won't touch each other. And if the distance between the centers is less than 2r, they should be intersecting, because this is r, this distance from here to here is r, and then again from here, this point to this point is r. So you can feel that from, let's say this is a or this is b, from a to b the distance is less than 2r. Anyways, so we have touching spheres, and the same kind of logic works here also. So this distance must be, this distance d, whatever this distance is, should be equal to 2r. Okay, and then the question is whether these spheres which are centered here and there, they touch each other or not. Do not go by the diagram here, because I am not showing you the actual projection. This is just an approximation. These spheres, of course, if you see in this diagram, in this animation, you see that they are not touching each other, but you have to do a proper calculation and verify. So this time we have to find out this distance from the red dot to the blue dot, and then what this distance is. If this distance, this orange distance here, this distance and this distance, they turn out to be the same, then we can say that if the spheres centered at this and this are touching, then the sphere centered at the red and the blue dot will also be touching. So let's check what's these distances. So let's join these two lines and let's think about the triangle ABC. ABC triangle is right angled at B, because this is, you might not be able to see this in this projection, but if you understand the geometry of the cube, then you can very easily realize that these two lines should be perpendicular. It's like, suppose your floor, so you have a room and there is a floor in your room, and you draw a line from the midpoint of one of the edge to the other, and then you can figure out that this line turns out to be perpendicular to this, the other line on the floor, right? You can try it in your room. Anyways, and then that distance here, let's call this distance the edge of the cube, let's call this A. So what happens, AB is A by 2 because this whole distance is A, and BC is also A by 2 because this distance is A and this distance is half of A by 2. So BC is also A by 2, right? Because here the parallelogram, you can see in this parallelogram, from B to C it's same as this distance here, this distance here. So AB is A by 2, BC is A by 2, and ABC is right angled at B. So we can use Pythagoras theorem. This is hypotenuse, AC is hypotenuse, and from there we can calculate AC to be A by root 2. You can do the calculations if you wish. And then now let's think about the orange line, and let's draw a triangle there. So and let's mark these points C, E, and D. So in the triangle C, D, E, okay. Now let's check. What is distance CD? This distance CD is same as this distance, which is A by 2. And this distance DE is half of the height of the cube, which is again A by 2, isn't it? So CD and DE are A by 2. And then again you have this right angle triangle, and you can apply Pythagoras theorem to calculate the hypotenuse, the length of hypotenuse CE, and this is written AE, sorry. This is CE, and CE turns out to be A by root 2 once again. So these are congruent triangles. In fact, ABC and CDE, they are congruent triangles. They have exact same dimensions. So now we see that AC and CE, they are equal. So distance from A to C and C to E, these distances are equal. So if spheres centered at A and C are touching each other, then the spheres centered at C and E should also be touching each other, right? I will also show you a 3D model in which you can visualize this. So remember now how I will show you this in the 3D model. So what I will show you that in the FCC unit cell, the atoms at the face centers, like the atoms centered at C and E, and the atoms centered at adjacent face centers, so C to E, the atoms centered at C and at E, they will be touching each other. Therefore, you will also see that the atoms centered at C, and then let's say this point is F, they will also be touching each other. So basically, you will have the atoms centered at the adjacent face centers. Adjacent means nearby. Adjacent face centers, they will be touching each other, but the atoms centered at the opposite face centers, they won't be touching each other. These two atoms will be far away. Let's say this point is G. So the atom centered at G and the atom centered at C, they won't be touching each other. I'm only talking about adjacent face centers, not the opposite face centers. Okay, so let's see. You can see that this cube here, this is an FCC unit cell, and I will start marking these spheres. So let's first have the atoms at the corners. So this now looks like this. The atoms at the corners, they are not touching each other. This you can see very easily. And then I mark the atoms at the face centers. 2, 3, 4, and then left and right. So now this is very difficult to see. Now from the top view, you can see that this atom here and this atom, or this sphere here, and this sphere, they are touching each other. Here you can see that they are touching each other. So this is very obvious, but what I'm talking about, that this sphere and this sphere, they are also touching each other, because these are the spheres at the adjacent face centers, not the opposite face centers. This one and this one. Okay, so this is sphere E and this is sphere M. I'll show you. I'll turn off all the other spheres and I'll keep only E and M. And now see. So you can see that they are, let me zoom in there. Yes, they're touching each other, right? From here, if you see, they're not, it's not that they're not touching each other. This is just the shadow of one falling on the other in this projection. But here you can feel this, right? They're touching each other. And the mathematical calculations also tell you that they should be touching each other. But if you take something, some other sphere, let's say like, where is this one? Okay, this one is also close by. Let's not take this. Let's take this one maybe. Just a minute. So this is also not the sphere I am looking for. This is also not that. Yeah, these two. So let's think about these two. They are at the opposite face centers, and you can say that they are not touching each other. Clearly, they are not touching each other. But if you take something which is at the adjacent face center, they are touching each other. So yeah, this is very interesting. They should be touching each other because the mathematical calculations tells you that they should be, and they do touch each other. Thank you very much. Have a nice day.